Welcome to this video, Subtractors. In this video, we will explore the fundamental concept of subtractor circuits in digital electronics. Just as adders are essential for performing addition, subtractors plays a key role in digital systems by enabling subtraction operations. We will begin by understanding the two main types of subtractors, the half subtractor and the full subtractor. Each of these circuits serves different purposes and has distinct configurations. A half subtractor is a combination logic circuit used to perform subtraction of two single bit binary numbers. It has two inputs and two outputs. The inputs represent the minuend and subtrahend, while the outputs represent the difference and borrow. In this half subtractor circuit, A represents the minuend, the number from which another number is to be subtracted, and the B represents subtrahend, the number to be subtracted. Similarly, the outputs D represents difference, the result of subtracting B from A, and borrow represents if a borrow is needed when subtracting B from A, when B is larger than A. Subtractor can be implemented using basic logic gates, an XOR gate for the difference and an AND gate combined with NOT gate for the borrow. The difference D is equal to A XOR B. This can be implemented using an XOR gate. The borrow is equal to A dash dot B. This can be implemented using a NOT gate and A followed by an AND gate with B. The half subtractor does not account for any borrow that might come from a previous stage when subtracting multi-bit numbers. For multi-bit subtraction, a full subtractor is required. For instance, if you need to subtract numbers that are larger than 1 bit, the borrow from the previous bit should be considered. And this is where the half subtractors limitations become clear. A full subtractor is a combinational logic circuit used to perform the subtraction of 3 bits, 2 inputs bits, minuend and subtrahend, and a borrowed bit from the previous stage. It produces two outputs, the difference and the borrow out. The inputs A represent minuend, bit to be subtracted from, and B represents subtrahend, bit to subtract. B in represents borrow from the previous stage. Similarly, the outputs difference represents the result of the subtraction, and B out borrow out, which indicates whether a borrow is needed for the next stage. The difference is the result of subtracting B from A with the consideration of the B in. This can be expressed as difference is equal to A XOR B XOR B in, where A XOR B gives the result of subtracting B from A without considering the borrow. Adding B in accounts for any borrow from a previous stage. The XOR operation is ideal for binary addition and subtraction as it gives the record difference for every possible combination of the inputs. When A is equal to 1, B is equal to 0, B in is equal to 0, the difference is 1. And when A is equal to 0, B is equal to 1 and B in is equal to 1. The borrow record here and the difference is 0. Borrow out determines whether the subtraction of A minus B requires a borrow for the next higher bit. For a borrow to occur, several conditions must be met. B is greater than A. The previous stage record a borrow and A is too small to cover it. The expression for borrow out is A dash multiply with B plus B dot B in plus A dash dot B in. For example, when A is equal to 0, B is equal to 1 and B in is equal to 0, the borrow out is equal to 1. Here, a borrow is needed. When A is equal to 1, B is equal to 0 and B in is equal to 1, the borrow out is equal to 0. Here, no borrow is needed. Here are the advantages of half subtractor and full subtractor circuits. Simple design. Half subtractor easy to implement for basic single bit binary subtraction. Foundation for complex operation. It is essential for building more complex circuits like ALUs. Hardware subtractors perform subtraction quickly. It manages borrow efficiently in large operations. Work well with adders. It can be used with adders for 2's complement arithmetic simplifying subtraction. Here are the disadvantages of half subtractor and full subtractor. Limited to single bit, only useful for simple operation. Borrow management needs extra components to handle borrowing, increasing complexity. Increased complexity for large numbers, multi-bit subtraction records, cascading, which complicates the design. Less efficient than adders. Adders using 2's complement can perform subtraction more efficiently in some cases. High power for large operations. Multi-bit subtractor consume more power. Thank you for watching.